Welcome back to the course Modeling Combustion with Answers Fluent offered by IDAL Systems. In today's class, we will discuss about partially premixed combustion model. So we'll discuss what is this model and what are the steps involved in modeling such kind of problem. So till now we have discussed premixed combustion and non-premixed combustion and how these two combustions vary. So partially premixed combustion is combination of both premixed and non-premixed systems because these systems are premixed flames with non-uniform fuel oxidizer mixtures, and so this model is also a combination of non-premixed and premixed combustion model. So when we have premixed jets discharging into a quiescent atmosphere or a system with lean premixed combustors with diffusion pilot flames and or cooling air jets, then we can use this partially premixed combustion model of fluid to simulate such kind of problems. So how these two models are combined together into a one model, that is partially premixed combustion model. So the strategy is straightforward. That is, the reaction progress variable C is used to track the location of the flame, which we call as flame front. Then before the flame front at C equals to 0, the mixture is unburnt and the mass fraction and other variables are computed using pre-computed mixture fraction PDFs. Whereas inside the flame, a combination of the two models is used. In the burnt area, that is at C equals to 1, the equilibrium mixture fraction is computed. So this way we can simulate a partially premixed system using partially premixed combustion model offered by ANSYS Fluent. The key features of this model. So ANSYS Fluent offered two types of partially premixed combustion models, that is thin flamelet model and flamelet generated manifold. So in thin flamelet model, it assumes that the premixed flame front is infinitely thin and that within the flame brush, the thermochemistry is described by a linear combination of unburnt and burnt mixtures. Whereas in flamelet generated manifold method, it assumes that the thermochemistry states in a turbulent flame are similar to the states in a laminar flame, and it parameterizes these by mixture fraction and reaction progress. So one have choice of using any of the model from both. Then there are some limitations of this model as well, that the single mixture fraction approach is limited to two inlet streams, which may be pure fuel, pure oxidizer, or a mixture of fuel and oxidizer. Then the FGM model which we discussed is only limited to C equation partially premixed model. So if one is using the FGM method, then they are limited to use C equation model only for calculation of turbulent flame speed. Next, we will see the steps involved in modeling partially premixed combustion model in ANSYS Fluent. So these are the 6 steps which one has to follow when they are carrying out the simulation for the partially premixed systems using this model. So we will discuss each of the steps in detail in further slides. So let's start the first step, that is we have to enable the partially premixed combustion model and we have to set the related parameters. Then we have to generate a PDF lookup table. So when we have enabled our turbulence equation, then we have to go into species and we have to enable the partially premixed combustion model. Then there are other options like inlet diffusion, compressibility effects, etc. One can follow any of them. And as we saw in non-premixed combustion modeling, we have to set the chemistry, we have to set boundary parameters, control parameters. Then we have to calculate the PDF lookup table. Same thing we have to follow here, just that this model is combination of both premixed and non-premixed. Some of the parameters will be included in model setup and some of the parameters will be included while we set up the boundary conditions. So we have to specify our boundary species and their composition in mole fraction or mass fraction, the temperatures of the streams through which air and fuel will be entering. And then we have to provide, if we are using any flamelet model, then we have to specify those parameters as well. In tables, we have to calculate our PDF table. Then comes the third step, that is we have to define the physical properties for our unburnt mixture in the domain. So what ANSYS Fluent will do is that it will automatically select the pre-PDF polynomial function for laminar flame speed, indicating that the piecewise linear polynomial function from the PDF lookup table will be used to compute the laminar flame speed. Earlier in premixed combustion modeling, we have seen that laminar flame speed and turbulent flame speed are the main parameters when we are dealing with the premixed combustion problem. So one has to determine both of these flame speeds in order to analyze the premixed combustion results. So same here, to calculate the laminar flame speed, the PDF table which we just calculated, ANSYS Fluent will automatically select this pre-PDF polynomial function for our laminar flame. So based on what mixture fraction we are using, PDF table will calculate a polynomial function for the variation of mixture fraction versus laminar flame speed. So when we enter into materials under laminar flame speed, we can see that the PDF polynomial function is already defined and we can go with that. Otherwise, one can select a constant value or a user-defined function according to their problem. Then comes the fourth step, that is setting the boundary conditions. So here one has to be very careful while setting the boundary conditions, because here we will be setting boundary conditions for pre-mixed as well as for non-pre-mixed combustion model setups. That is, for pre-mixed flows where unbound mixture will be defined with the progress variable C equals to 0, and for burnt mixture which will be present at outlet, there we have to define C equals to 1. So this will give a range for the flame front for unburnt and burnt mixture. Then we have to specify our fuel concentrations which we just defined in our model setup, that is mole fractions in our boundary species. So we have to specify the mean mixture fraction and its variance at our fuel inlet position. So these all things will be set up in the boundary conditions, and one has to be very careful when they are setting up this boundary conditions, because even if one step is missed, then the combustion won't be initiated and the flame won't be visible. So the next step after setting boundary conditions is to initialize the value of progress variable. So better initialization is to patch an initial value of 0, that is unburnt mixture, upstream of the flame holder, and a value of 1, that is burnt, in the downstream region once the boundary conditions are specified. So this initialization will help in patching value of C equals to 0, because if one is dealing with a bigger domain and a complex problem, then this patch will help in maintaining an order for the burnt and unburnt mixture. So once everything is set up, then we have to go and we have to solve the problem. While solving the problem, one has to carry out a cold flow simulation first, and then they have to go for the hot flow. Otherwise, they won't be able to patch proper values of C if both hot and cold flow simulations are solved at a single time. So even in post processing, here we can generate graphical plots or alphanumeric reports of the following terms. So here what all things we saw in premixed combustion model and non-premixed combustion model, same parameters we can analyze in partially premixed combustion model for post processing. So the summary for today's class is that we have discussed what is partially premixed combustion model. So these partially premixed combustion systems are nothing but premixed flames with non-uniform fuel oxidizer mixtures, and that's why this partially premixed combustion model in ANSYS Fluent is combination of both premixed and non-premixed combustion models. Then we have seen some examples of this system that are premixed jets discharging into quiescent atmosphere, then lean premixed combustors with diffusion pilot flames. Then we have seen two types of partially premixed combustion models are offered by ANSYS Fluent, that is thin flamelet model and flamelet generated manifold. Again, we have seen some limitations of partially premixed combustion model, that single mixture fraction approach is limited to two inlet streams, which may be pure fuel, pure oxidizer, or a mixture of fuel and oxidizer. Then we have seen steps involved in modeling partially premixed combustion model. So the references for today's class are present here. In next class, we will start with post-processing of combustion results. Thank you.